In this Grasshopper tutorial, I want to show you how you can use a simple Hankins method, which I will explain now, to produce a Islamic pattern, a parametric Islamic pattern. We can change the numbers, as you can see here now. I'm changing the number from two set of grid points, and we can also make some point attractors in the modeling and use something like a point which will affect the overall pattern. So basically I'm going to use point attractors to model, you can see here, the stars based on the distance between the centers, which I will explain, between the centers of the polygons and the point attractors. Basically this method is based on the Hankins method. You can see it here. We have Hankin methods, which uses polygons in contact. You can see we have a polygon 4, 8 here. So we have these polygons here. You can use other polygons, but I have put the article in the website so you can download it, Islamic star patterns from polygons in contact. And we're going to just choose one, the first one, and model it in Grasshopper so you can understand how we can use Grasshopper and methods and tools to produce the results and see the stars. Okay, to start from scratch, first I have to explain the grid in the article. So you can see that there is an example of star patterns constructed using Hankins method, and for these methods we have this one. You see that there's a polygon with 8 edges and surrounded with 4 rectangles or squares. So this is the grid we want to make. We can simply have a simple rectangle or square grid, but this is an advanced grid. So you can see that those grids are changed from the regular rectangular grid into polygons which are in contact. So I'm going to use Rhino for this because it's going to take time if you want to model this in Grasshopper, so you can easily see how I make the grid. Okay, now I'm going to just zoom in, and we can go to the polygon here and put this to maybe number of sides 8 and use the edge. Okay, let's just draw this. This is the first polygon we need. Next we need an square here, so I'm going to use this again, but this time 4 sides and edge, and I'm going to put this here. Okay, we can again do this. We can use area centroid, use this array polar, number of 4 times, and here we go. We can put these into another layer, so I'm going to use shift, change layer to layer 1, and here we go. Okay, so how can we make the grid easily? The best thing you can use is to delete this and okay, and this one, and just copy this polygon here, and we're good to go. And that is because I think we need this one too, perhaps. Okay, when we use the array method, that's an array linear, we use it for 5 times, and we just say we want this here. You can see we can simply make this, and now we can just again array linear number 5 times from here to here. So basically we don't need this. This is we want to delete this. This is the base polygon we need, and we can just array that. So we can say array, and now I'm going to use the simple array tool. Okay, let's delete this and say we need 5, 5 and 1, and now we can see how we can manage this to put them together. When we put that here, we have it locked, and now we can delete the corners. Okay, we don't need these, and we don't need these polygons, and you can see that we have 5 to here and 5 to there. And this is how you can do this in Grasshopper, but that's going to take time. So I'm doing this in Rhino, so it's a little bit easier. Okay, so now we're going to go to the Grasshopper and go to the Params menu, put a curve in the canvas, and let's just choose the layer default, select objects, and set these to the curves. So this is the first set of curves we need. Okay, let's go to the next one, layer 1, select objects, set these here, and we have the layer 2. So you can see that we have 2 set of polygons here. The first is the 8 side polygons and then the squares. Okay, let's work with the 8 sides, and then we can just use that for the squares. I'm going to need point attractors here, so we can just go here and use to the surface and go to the bounding box, connect this to the polygons, right click and use the union box. Okay, and now we can evaluate our point attractor from this box. So I'm going to use evaluate surface. You can check out the evaluate surface Grasshopper command tutorial. We need a reparameterize, we need an MD slider. You can also find this in the course, in the point attractor, multi-point attractor course, or the parametric points in the course. We have explained that. Okay, so let's just check this out from the corner here to corner there. Okay, these are 2 point attractors we needed, and now we're gonna use these point attractors to produce the patterns. So you can see here. Okay, what happens and what is the steps we need to produce the pattern? First of all, let me explain with this polygon. We have a center. We can connect the center to the corners with lines. Okay, so this is going to just be all the way, and then we're going to extract the midpoint of the edges. So I'm going to show this with red, and we have the midpoints, okay, and so on. And then we're going to give a parameter here moving on this line, so we can just move on this line up and down, and whenever we just choose whatever we choose, we can just connect these set of points together. Okay, so I'm going to connect these, and you can see that the star will emerge from the polygon, and then we can delete the polygon at the end. So we're going to use Grasshopper for modeling this. I'm going to take the area tool to extract the center of the polygons. Okay, then we need a line to the corners. We can go to the explode tool and explode the polygons into vertexes, and then connect a line. Okay, line here, simply a curve tool, line here to connect 2 set of points, and we have the corners and the centroid. So you can see that this happens, and that means that the groups are not right. And I'm going to explain that in the course about the groups and data groups, or you can just check out your question section 1. We talked about flatten, graphed, or these things, but you can see that these are groups of 9 vertices, and this is 41 centers without a group. So I'm going to just make this centroid to a group. I'm going to right click and use the graphed, and here we go. You can see that we easily connected the centers to the vertices. Okay, now we need a tool to evaluate this line, so I'm going to use the evaluate curve tool, give this line here, and if we give this a number from 0 to 1, you can see that we can just move these points. Just turn this off, from the corners to the center, And here's the first set of points we need. Okay, the next one is the center of the edges. So I'm going to go and use the point on curve tool and go to the segments. So I'm connecting this to the segments, and we're just having the half of this. It's exactly the mid of the curve. And here we go. We have two set of points which we have to connect to have the star pattern. So what we will do here is to use a tool called weave. That's a weave pattern. I will talk about weave in a Grasshopper command tutorial so you can understand what weave does. But for now, we can just simply pick between stream of data. You can just have more data if you want, or less data if you need, but you have to have at least two set of data here. So this will be the first one, and this will be the second one, and we can give this a pattern here. You can see it has a 0 and 1. It means 1 from the 0 and 1 from the 1. So we're just picking between datas. So it's just 1. So it's 0, 1, again 0, 1, and then 0 and 1. So we can just make the pattern happen. So you can easily use weave, and then we're going to use a polyline to connect these. Okay, you have to just control the 0 and 1. I'm going to change the 0 and 1. You can see that it's going to be okay. And that's because if you use this one and then okay, this one, let's just assume that we put this back. You can see that it just took this one, then this one, and then this one. So it's going to be wrong. We have to use the pattern 0 and 1 and change between the 0 and 1 so you can get the results. Okay, so check this out. If I give this the pattern something like set multiple integers and say 0, 0, 1, 1, you can see that it will just take 0, 0, and 1, 1, then again 0, 0, 1, 1, and you can see that I have produced a simple parametric pattern here without even just thinking to that. Okay, we can just turn everything off. We can turn this off, and you can see how easily I can produce a pattern without even thinking to that, because I have made a pattern in the weave section. So maybe we just need something like 0, 0, 0, 1, 1, 1. I don't know what happens here. Maybe another pattern emerges, and this one is not a really good one, so we perhaps go back to 0 and 1. Okay, so here it is. You can see the Islamic star pattern. Simply with changing this, we can produce the pattern of the stars. And now we need at the squares here, check this out, at the squares, we need another pattern here. So we can just simply have all of this algorithm here and just copy and paste it and use this one. Okay, and turn this off, and you can see that we can work also on the squares, and we can change this to have harmony with the other stars. You can see here. Okay, we can change this and produce the pattern. So now we need the point attractors. I'm going to have a separate course on Islamic modeling, parametric Islamic modeling. So I'm going to explain arcs. I'm going to talk about Islamic star patterns and use other methods. But for now, let's just have this. We can use this point attractor to affect the stars. And how we can do this is simply, let's go back to the polygons. And here we have the centers. Okay, let's just give this a center. And now we can just, let's check this out. Okay, now we need a CP point here. I've explained this in many of my tutorials. I guess you don't know about closest point because you have not watched any of my tutorials, and I have also explained the closest point in my Grasshopper course. But for now, so I've explained about this in the Grasshopper course, but what I'm going to just have a quick tip on it. You have to connect the point attractors to the cloud and the point grid of points, which is the center of this polygons, to the point. And now we have the distance here, and the distance is between exactly these set of points going to pick this point attractor, and these set of points going to pick this one. It would just calculate the most near point attractor which we connect to the cloud, and we will have the distance. Okay, so what we need here is a remap tool. You can download this from the website. I've explained about the remap. It's a simple remap number tools and why we need that. Okay, so it's going to make it easy. So we're going to use a remap and then give this to the parameter. So what we need here is a number between 0.2, maybe 0.8, and we're going to give this instead of the fixed number we using here. But remember, first of all, if we don't flatten the remap, the data will be lost, and that is because of the groups. Let me explain this. Okay, we have the distance in groups, and let's see what remaps gives us. We want to take these data between 0.2 and 0.8, and it comes here that each remap goes to one group and it checks it out. It doesn't have an minimum and doesn't have a maximum, so it doesn't know what to do, which one is going to 0.2 and which one is going to 0.8, and it gets confused. So it will just add up these two. 0.2 plus 0.8 will go to 1 and divided by 2, so it's all going to be 0.5. So remember, first of all, the most important thing that always the input of the data input of the remap must not be in groups. So you can just simply right click here or right click here and use the flatten tool to just make all the data in one group. So it will compare the minimum to 0.2, the maximum will go to 0.8, and all of the data will be between 0.2 and 0.8. And then we can give this here to the parameter. Okay, so what will happen here is that you can see that it doesn't show it right. Again, we have a group here, and you can see that. Okay, let me show you. We have 41 groups here, and all of the data is not in groups, it's just in one group. So now we need a right click and a graph, and here we go, and it's good to go, and we can just turn everything off. Okay, and here it is, and these are the point attractors, and you can see how I'm going to affect these simply by changing the location. Okay, I just skipped many points here because this is not going to be a complete course on the Islamic star pattern, but I have just gave you some tips. So first of all, we just made it with one number slider, and it was easy. You can understand that. Now we need multiple data, so we use the distance between the point attractors and the center of the grids, and we used the closest point. I've explained that before, so perhaps you have to have more information in Grasshopper, and you have to have more skills to understand. But for the tip, we explained that the grid of points goes to the point, the cloud goes to the point attractor goes to the cloud. And then we have the distance. I've explained why. And now, because of the remap, I've explained we have the flatten because we have to go between 0.2 and 0.8. And again, another graph because we have a group here and we need a group again here. So all of the data goes exactly to the right group, and we have the results on, and here we go. You can see simply how I'm just affecting this, and you can also maybe give it a one number. It's that exactly the same as the before we modeled it, and now we can give it more aggressive numbers, okay, to 0.0 to 1, and you can see perhaps it's better to put it 0.1 to 0.9, and you can see that this will affect the pattern. So we can just use this exactly as the same I'm going to maybe just, okay, we need exactly this one, so I'm going to copy this. We have the rectangles here, so I'm going to copy and paste this. Okay, we have to just fix some data here. First of all, we have the squares, so just let's turn this off and explain this. Then we have to compare between the point attractors. So the points is going to be exactly the same as the points we had before. So the points is going to be exactly the same point attractors. The center of the grid is the center of the squares, and that's right. Okay, then we had the CP, and that's okay. And this one will work for the squares. So you can see that if I change this, let's move this one, you can see that it affects the center of the squares also, and that's okay. So we just turn this off, and we have two set of polylines. Okay, here we go. We can just change this to maybe 0.2 to 0.6, this one too, and here we go. This is the point attractor, and we can simply, let's just turn this on. We can simply affect the grid. So this was the first step you can take to model the Islamic star pattern, and you have you can now understand how you can model the other grids. You can just model these and use the point attractor or the curve attractor or the image. You can use images, you can use anything, but you have to just have this output and remap this to your evaluation. So then you can just bake these, and we can simply extrude them. Just use the control key to extrude these out, and you can see that they are okay. And then you can just take this and put it on a surface. So let's just explain this in Rhino, because we explained how you can move Voronoi cells into a surface in another tutorial, so I'm just not going to again talk about that. So let's just rebuild this to maybe 30, 30, and draw a surface from this corner. Maybe we just need a bounding box. Yep, then we can explode the bounding box. Okay, and now we can just send this on the surface. So I'm going to choose everything except the surface, and then use flow. Okay, flow along a surface, and then use the base surface and the target surface. Okay, so we have this here, and you can see how we can just move this into another surface as we want, and we can also delete the surface and have this modeled. Okay, so this was exactly a step-by-step tutorial of how you can use simple algorithms to produce the patterns and understand how it operates. You can use this for other patterns, and feel free to ask or comment underneath this video. Thanks for watching. Thank you for your feedbacks, and be sure to subscribe to the channel so we can inform you for new video tutorials, and hit the bell subscription, the bell icon you see near the subscribe button, so you can get the first information about our videos as soon as it goes online, and we publish it in our channel.